In section 4.5, we're going to be looking at exponential equations. To solve, we must get the same base on each side, and then we're going to set exponents equal to each other. So when we look at this, we want to be able to rewrite them with the same base. So this is a base of 2. Can I rewrite 16 with the base of 2? 2 to the what power gives you 16? So we say 2 to the 4th. Once that happens, once our bases are the same, we set our exponents equal to each other, so we get x equals 4. On this one, we want to try to rewrite them with the same base. The base is 5, so that's going to be 5 to the what power equals 125. Once we do that, then we say 3x equals 3. And when we solve for x, we find out that x equals 1. And the next one, we have a base of 2 over here. We're going to try to write this one with a base of 2. That's 2 to the 3rd power. Then we're going to set this equal to this. So we have 3x minus 5 equals 3. And then we're just solving for x. So we're going to divide by 3 now, and x equals 8/3. Over here, the first thing we want to redo is rewrite it with the base of 3. So that's 3 to the 4th power is 81. Now, I need this to be not a fraction. So if I want to move this up top, my exponent just becomes negative. So I'll leave this side alone. And when I move it above the bar, it becomes a negative 4. And so now that they are equal, my base is the same. I say x equals negative 4. Now, I can't rewrite 8 with the base of 4. And I can't rewrite any of this 4 to the 1, so I try a smaller base. I can rewrite 4 as a base of 2, and 2 squared is 4. I can't leave this off, so I just carry it over. 8 is 2 to the 3rd power. Now that I have a base of 2, I can set this equal to this, so you get 2 to the x plus 3 equals 3. We want to distribute 2x plus 6 and solve. Then divide by 2, and x equals negative 3/2 for this. Okay, if we're unable to get the same base on both sides, then we have to try something else. Then we're going to take the log of both sides or the natural log both sides. If there's an e in the problem, that's when you use natural log. If there's not an e, then you're going to take the log. So the next example, we're going to say I cannot get 5 and 13 to have the same base to rewrite it, so I'm going to take the log of both sides. The log of 5 to the x is equal to the log of 13, and I'm going to use my properties that we learned the other day. So an exponent can be pulled out front, so that's x log of 5 equals the log of 13. And if I want to get x by itself, I'm going to divide both sides by the log of 5. Now, I'm going to put log of 13 divided by log of 5 in the calculator. I'm going to get approximately 1.5937. Over here, I cannot get these to have the same base, and because this is an e, instead of taking the log of both sides, I'm going to take the natural log of both sides. Logs and natural log have the same properties, so I can take this exponent, and I got t times the natural log of e equals to the natural log of 25. We recall that the natural log of e is equal to 1. So if this becomes 1, that's 1 times t, which is just, I'm going to show that 1 times t is equal to the natural log of 25, and then t equals, when you put natural log of 25 in the calculator, you get 2.189.